Today's lesson is systems of linear equations. Now, we all know that we can graph the equations, but that's going to require us to first solve for y for each one of these equations. So these are three separate examples here. But it would require us to solve for y in each of these equations and then plug it into the calculator. So it's probably the more difficult route than actually doing our two normal ways, which would be substitution and elimination. Now, in general, it's easy to figure out which one you want to use based on the problem type. If you ever have any of the variables without a coefficient or a number in front of them, then substitution is going to be an easy way to do it. However, with those, you can always use elimination as well. So it depends on your own personal preference and how you like to, or which method you like to use. Okay, so we're going to start this first one off. We're going to do substitution for this. And to do substitution, I have to get one of the variables by itself. So I'm going to get the y by itself and just subtract the x. This gives us y equals 6 minus x. And now I can take this 6 minus x and plug it in up here for y. So it's negative 5x minus 9 times 6 minus x equals negative 26. Now, in our Keystone lesson yesterday, we learned about the distributive property. So we're going to have to distribute this negative 9 to both terms. So it gives you negative 5x minus 54 plus 9x equals negative 26. Now, because these are both on the same side, both these x's, we can combine our like terms. Having some technical difficulties. I don't even know if you can hear me right now. Alright, we're back on. So we're going to combine our x terms, negative 5x plus 9x, that gives us 4x minus 54 equals negative 26. Add the 54 to both sides, you get 4x equals, and then it's 54 minus 26. I don't know what that is off the top of my head. So it gives 28. Divide by 4, so x equals 7. Now you take that x equals 7 and you plug it in to the other equation. So you're going to plug it into this equation. Gives you 7 plus y equals 6. So if you have 7 plus y equals 6, subtract the 7 over, you get y equals negative 1. And so your final answer would be 7 comma negative 1. So that's using substitution. The other method we use is elimination. And so let's use elimination with the second problem. Elimination is where we eliminate one of the variables. So we're going to want this, in this case, we're going to eliminate the x. So we're going to want this coefficient or number to be the opposite sign of negative 8. So you're going to want it to be 8, but a positive 8. And so in order to make that positive, we're going to multiply by a negative 4. Now the top equation just carries down. Always rewrite it. And the second equation is going to become positive 8x minus 4y equals negative 64. Now negative 8x, now we just add these two together. So negative 8x plus 8x, those cancel. Negative 5y minus 4y, that gives you negative 9y. And 10 minus 64 gives you negative 54. Then divide by the negative 9, you get y equals 6. Now you take that y equals 6 and plug it into either one of these equations in the original. Now I'm going to plug it into this one because I don't have to multiply it by anything or do anything with it. So this will be negative 2x plus 6 equals 16. And now I solve. Subtract 6. It gives you negative 2x equals 10. So x equals negative 5. So your answer would be negative 5, 6. And this ordered pair represents the point where the two lines would intersect. And that's just the solution. Okay, for this last one, we want to use elimination, but it's not going to be easy because this is the more difficult type. We have to multiply both the top and bottom by a number. So we can't multiply 2 by anything to get negative 3. So we look for a common multiple. It should be 6. So in order to get negative 6 up here, I would multiply this by 2. In order to get a positive 6 down here, I would multiply by 3. So that's going to give us negative 6x plus 6y equals 2 times 24, which is 48. Then on the bottom, it's positive 6x plus 6y equals, and then it's 24 times 3, which would be 72. Now we just add them together. Negative 6x and 6x cancel. Now it's plus 6y and plus 6y, so it's going to give you 12y. And that's going to give you 120. So we just add those two together. Divide by 12. You get y equals 10. Now you take that 10 and you plug it back into either equation. So we need 2x plus 2 times 10 is 20 equals 24. Subtract 20, you get 2x equals 4. Divide by 2, x equals 2. So your final answer would be 210. Now you can check these answers by plugging them in to the equation. So if I plug this in here, that's going to give me negative 3 times 2, which would give me negative 6, plus 3 times 10, which is 30. Negative 6 plus 30 equals 24. So that's true because it was equal to 24. Okay, moving on. You're always going to have a word problem that goes with it. So flying to Kampala with a tailwind, a plane averaged 158 kilometers per hour. So tailwind is a wind that is blowing at the back of the plane, pushing it forward. And so we would have the speed of the plane, which we'll call x, and the speed of the wind, which would be y. And those combined would give you 158. Then on the return trip, the plane only averaged 112. So that's going to be x, speed of the plane, minus the speed of the wind to get 112. Now elimination is going to be the easiest here because we have a y that cancels with this negative y. And so we don't have to do anything with them. We just add them together. It gives me 2x equals 270. Divide by 2. You get x equals 135. Now really I should have defined my variables in the beginning and said x is speed of plane and y is speed of wind. Because by doing this, now I know that this is my plane speed. So make sure you put your units in, 135 kilometers per hour. And then it may ask you to like write a sentence to describe what your answer means. But you would say the plane is actually flying at 135 miles per hour or kilometers per hour. Okay. The second one, we need to find the speed of the wind. So we're going to take that 135 plus y equals 158. And just subtract the 135. That gives you y equals 323 kilometers per hour. And so if you had to write a sentence for this, it would be the wind is traveling at 23 kilometers per hour. Okay, you can go ahead and do the solving linear or systems of equations questions.